So question 1 now asks, what do you know about angle 1 and 2? What type of angles are 1 and 2? We have two parallel lines with a transversal. What kind, Megan, are those? They are acute, you're right, but that doesn't help us talk about their measurement. And so you're not wrong. I was just wondering if there's a label that's more specific than that. So I'm actually kind of glad you said that. That's a true statement, but doesn't help us here. What else do we know about those other than they're acute? Tatum? They are corresponding. What is the definition of corresponding angles? Because I know some of you don't know that. They're corresponding, that means what? Do you remember, Tatum?
Oh,
sure, if you know.
They are...
Katie, can you explain it? They, oh, you're right. They're corresponding angles, which means angle 1 and angle 2 are congruent. What does congruent mean?
Equal.
They are equal. They have the same measurement. No one can tell me what the definition of corresponding angles are. Oh, some of you are going to have to review from last year. Ty?
The same side on the interior.
Ooh, you're super close. They're on the same side, but they're at top right.
Oh,
Top right. They're in the same location. Okay? So a corresponding angle are two angles formed when a transversal, this line cuts through two parallel lines. When they're in the same location, in this case top right, that means they're congruent or the same measurement. I'm with you, Mrs. Smith. It's coming back to me. Yeah?
yeah.
Do I have to sing the song? Don't make me sing the song.
What song?
It's all coming back to me
no,
now.
no.
Shh, shh, shh. That's right. It's now on videotape. Awesome. 2 says, you're welcome, Emma. Angle 3 and angle 4. What do we know about angle 3 and angle 4? What's their label? What do we know about them? That they are, Alyssa, they are corresponding. How do you know? What's the definition of corresponding angles? Yeah. They are congruent. They have the same measure. Tell me why. How do I know when two angles are corresponding to each other? Someone tell me that definition. It's about to be your ticket out the door. How do I know when two angles are corresponding? Luke. They're in the same location, and in this case, the upper left-hand corner, when what happens? You have a two parallel lines cut by a transversal. Good. So 3 and 4 are also corresponding angles, which means angle 3 and angle 4 are congruent. Absolutely. Question 3 then says, what can we conclude, what conclusion can we come to about triangle RST and triangle USV? First of all, does everybody see those two triangles? Do you see this little triangle here, RST, and this bigger triangle, USV? So I could, if I wanted to, pull out, you don't have to draw this part, SRT here, and compare it to triangle USV. That's an important thing. Can you see those two triangles inside one another?
Yeah.
Okay. We know that R corresponds with U, right? Because they're corresponding.
Yeah.
We also know that 3 and 4 correspond with each other because they're corresponding. Remember, if I have little things, that's right, and someone just said S has to be the same because it's the exact same angle. Good work out of you, Quincy. Ty? Do you know that for sure?
No. Because you did not measure the
Shh.
angle.
Tell me.
Because if all 4 or all 3 of them corners were equal, the other one.
Do you know that the side lengths for sure are equal?
Looks like that the two that are off are longer than the bottom one. Both of them are the same.
Do you know for sure? Have we proven it? No, it does look like it the way I drew it, but it wouldn't have to be. What we do know for sure is that these three angles correspond to those three angles, and they are the exact same measurement. What does that mean then about these two triangles? Notice that R and U correspond to each other, so they're listed first. S, of course, corresponds with S because it's the same angle. And T and V correspond with each other, so they list them that way on purpose. And we always name a shape with the letters of its corners, and then if it's a parallelogram, you'd put a parallelogram in the front. What can we conclude? What can we come to understand about these two triangles now that we know this? What do we know, Luke?
Triangles are similar
How do you know the triangles are similar?
because of their angle measurements are all the same.
And remember, they have to be the same shape. They have to have the same angle measurements. Ooh, what's the third thing? What's the third thing to have a similar figure? There has to be a what? Two words? S, F, has to have a scale factor. So, I'm going to put one little squiggle there because this means that they are similar. And I love math because you don't have to write as much. Okay? You do have to know what the symbols mean though. Okay? So this says triangle RST is similar to triangle USV. Because all the angles are the same, and the reason there's a scale factor is because these two lines are parallel, okay? That has to be proportional. Could I also stick this angle here and put this triangle in U and have those two end lines be parallel? Could I move this triangle and put it down in this corner?
Because S wouldn't line up with that.
But would R line up with U
Yes.
and be the same angle? We said that they're the same, and then those two lines would be the same. So it would require a lot of calculus and some trigonometry to prove. We are not proving that they're similar. We are conjecturing. That means we're taking an educated guess, and I'm telling you that's a true mathematical statement. But it's not like earlier in the year when we proved something mathematically, because we don't have enough information. It's beyond the scope of this class. Okay, but know that that's a true statement. It works for triangles. Does it work for rectangles? Are all rectangles similar?
No.
Yes.
Couldn't you have a long, skinny rectangle and a big, fat rectangle and have them not be the same general shape? So even though their angles are the same, there's not a scale factor. What about squares, though? Are all squares similar?
Yeah.
Yes, because the side lengths would have to be the same. Okay? So it works for triangles. What about circles? Are all circles similar? Absolutely. Absolutely all circles are similar because they could share the same middle point. And you could either do the diameter or the radius. So some shapes, it works for. Triangle is one of them. Okay?
Mrs. Smith.
Yes.
Isn't a square a rectangle, which is a special rectangle?
Square is a square, yes, is
Told you
a
guys.
special